Hey everyone, we're going to get started looking at our Chapter 1 practice test. And as you recall, the Chapter 1 practice test is going to be all about graphical displays and interpreting them, as well as a few things on describing distributions, and we'll see where that takes us in a second. All right, so we have number one, a survey records many variables of interest to researchers conducting the survey. Which of the following variables from a survey conducted by the U.S. Postal Services is categorical? So we're going to talk about each one of these individually. Now, if you remember, a categorical variable means that if you answer the question, then the answer is probably going to be yes or no. As in, do you belong in this category, yes or no? Or do you belong in this category, yes or no? A quantitative variable is a variable where the response is going to be a number, and that number is going to have some kind of a meaning to it. So, just saying 3 is not necessarily going to make a quantitative variable. So let's take a look at letter A. The number of people, both adults and children, living in a household. Okay. How would you answer that question? How many adults and children are living in your household? Well, you'd probably say a number like 4, 5, maybe 9, like my parents. I don't know. And that number would have a meaning because 9 people living in a household means something different than 4 people living in a household. So this would make letter A quantitative. Letter B, county of residence. Okay. So how would you answer that question? Well, do you live in LA County? Yes, I do. Do you live in Orange County? No, I don't. Do you live in Tulare County? No, I don't. So the answer to the question really is a yes or a no. Or sometimes you might look at it as the answer is going to be, which category do I belong? So that one, letter B, the county of residence, that's a categorical variable. Letter C, household income before taxes. Okay. The response to that, someone asks you, what's your household income? The answer is going to be a number, and that number is going to make a difference. If someone answered with $32,000, then that means a lot different than if someone said, $92,000. So household income is quantitative. Let's remember we're looking for categorical. Letter D, age of the respondent. Again, quantitative. If someone says, what's your age? You would probably say, 17. Well, that's a number, first of all, and that number is also different than if you had said, I'm 12. So it's a number. The number has meaning. You can order based on that number. So that's a quantitative variable. So it looks like our county of residence is our categorical variable. Okay, let's take a look at our question 2. A description of different houses on the market includes the following 3 variables. Which one of these is quantitative this time? So letter A, square footage of the house. The answer to that is a number, and that number does make a difference. If I answer that with 300, then that's a lot different than answering it with, say, 900. So the number that you answer has a meaning, and it's an orderable meaning. I don't know if that makes sense. Those numbers you can put them in order, and that order makes sense. Letter C, the electric monthly bill. I don't know why I skipped B and went to C, but the electric monthly bill, yeah, that's certainly an answer. The answer to that would certainly be a number. What's your monthly electrical bill? Oh, I don't know. It's, $120. That's a number. Kind of the same thing along those lines as the monthly gas bill. The answer to that question is a number. What's your monthly gas bill? So it looks like the correct answer that would put all three of those together, would be letter D, all of the above. Maybe I should do that in a different color because that is the correct answer, letter D, all of the above. Okay, below we have the histogram for the gold medal winning high jumps for the Olympic Games. What percentage of jumps were at least 7 feet, which would be 84 inches? Well, 84 greater than that. Well, I can't really see 84 here. I just know 84 is somewhere, somewhere around here, really. And so greater than 84 would really encompass this area right over here in blue. Over here we have percentage of, what is that? Percentage of cases? I'm having a hard time reading that. Maybe I should blow that up. Percentage of, come on, buddy. Percent of cases. Okay, so I'm not sure why it says cases. That makes me think it's something medical, but it's not medical. So, well, we could just take a look at these numbers then. This bar right over here, maybe I should draw a line. Yeah, let's draw a line. This bar right here, that would be right around 10%, it looks like. Oops. So that's about 10% right there. And the next one, that second bar from the right, that would be at what? Ooh. Yeah, that looks like right around 25%. So 10%, 25%, maybe a little bit more, but it just says about. So we would expect somewhere around, let's see, 10 plus 25%, somewhere around 35%. So what we're saying is about 35% of the winning high jumps were 84 inches or greater. Probably a little more than 35, but it's really kind of hard to tell. Question 4. Professor records the values of several variables for each student in her class. Which of the following is categorical? So that's categorical and quantitative again. Okay, so score on an exam out of 200 points, we already said. It's quantitative if the answer is a number and that number has meaning. And so out of 200 points, so definitely your number is going to have meaning on that final exam. So that's quantitative. Final grade, A, B, C, D, F. What's your final grade? Oh, I got a C. Well, that's not an answer, or that answer is not a number. It does make sense if in order, but bottom line is it's not a number. So B looks like it would be categorical. And just for fun, we're going to go over the rest of these. The total number of points in the class, again, that answer is going to be numerical. Some number, so that's quantitative. The number of lectures a student missed, that's also a number, and that number does make sense in order. So that's going to be quantitative as well. Okay, number 5. Mrs. Richardson asked 26 seniors in her statistics class how many AP courses did they take during high school. Below is a dot plot summarizing the results of her survey. And it says to use a dot plot to create a box plot for the number of AP courses taken by the 26 seniors. And then describe that distribution. So there are 26 seniors in this survey, and we can divide 26 evenly in two. There would be the bottom 13 and the upper 13. And so there'd be the lower half of the data would be 13, so 1 through 13. students 1 through 13, and the upper half of the data would be students 14 through 26. Both of those contain 13 students, so the median would be whichever is between the 13th and the 14th students. So what I'm going to do is I'm going to actually also look at this graphically. So the lower half of the students is the bottom 13 number of AP courses. So this is 2, 6 students, 7, 8, 9, 10, 11, 12. There's 13 students. Those are the 13 students who are taking the least number of AP courses. And then we can divide that to the upper half. This is 1 plus 4 is 6, was 5. 5 and another 4, that's 9. 9 and another 4 is 13. So those 13 students in blue, those are the 13 students who are taking the most number of AP courses. Now, since it divides evenly in two, the median is going to be the average of the two that are closest together here. So basically, it's the average of 3 and 3. So the median is going to be equal to half of 3 plus 3, which of course is 3. Not a big deal. Okay, so that takes care of the median. Two other numbers which are a lot easier to find would be the minimum, which looks like 1, and then the maximum, which would be one of these guys over here. It would look like a 6. Now the other numbers that we're going to need are Q1 and Q2. So Q1, quartile 1, is going to be the median of these 13 students in yellow. So 13 doesn't divide in 2. So if I take away, so this is the thought process that goes in my brain. 13 is an odd number. If I take 1 away, that's going to be 6, or that's going to be 12. 12 divided by 2 is 6. So that means that the 7th student from the bottom or the top is going to be the median. So let's see how that works here. We've got 1, 2, 3, 4, 5, 6, 7 students. This person right here, that's the median. Because you'll notice that there are 6 students who have a lower number and 6 students, 1, 2, 3, 4, 5, 6, who have, well, in this case, equal to or greater than. So 6 students below, 6 students above. We're only looking at the yellows, of course. So that is Q1, quartile 1. That's going to be equal to 3. Now quartile 3, that's going to be the same process from 14 to 26. That's 13 students. And 13 is odd, so if I pop off the one that's going to be the median, that means that there are going to be 12 students. Divided in half is 6. So the 7th student from the bottom is going to be the median of the upper half of the data. So let's see, 1, 2, 3, 4, 5, 6, 7. So right over here, that's the median of the upper half of the data. 1, 2, 3, 4, 5, 6 students are below the median, and 1, 2, 3, 4, 5, 6 students are above the median. And of course, I mean the median of the upper half. So Q3 is going to look like a 5. So these are all the numbers that we're going to need for our box plot. So let's set up a number line so we can get the box plot going. Okay, here's our number line with the number of AP courses labeled across the bottom. And now what we need to do is, well, I like to tell my students to put a horizontal line at each part of the 5 number summaries. As a quick review, that 5 number summary, That's going to be the minimum, 1, Q1, which was 3, the median, which was also 3, Q3, which was 5, and the maximum, which is 6. So I'm going to go ahead and put a horizontal line on all of those. There's one for the minimum. That's going to be both Q1 and the median. Here's Q3, and here's Q6, or I'm sorry, the maximum. Now let's connect the, what are we saying? We're connecting the minimum with Q1. Ooh. I'm having a hard time here. Oy. That doesn't look good at all. There we go, that's better. Okay, and then we're going to connect the Q3 with the maximum. Let's see if I can make this a little better. Yeah, that's a little better. And finally, we're going to draw a box that contains Q1, the median, and Q3. Well, being that Q1 and the median have kind of collapsed onto the same number, well, this box is going to not look quite like we really want it to. Ooh, no, let's do this. There we go. That's better. So that's going to be our Q. That's going to be our box plot, really. And this is our minimum, which is 1. This is going to be Q1, which equals the median, which equals 3. This is going to be Q3, which equals 5. And this is the max, which equals 6. So don't be afraid to label your 5-number summary right on top of your box plot if it's kind of unclear. Okay, so how can we describe this distribution? Well, describing distribution comes down to 5 things. No, 4 things, I'm sorry. First of all is shape. Now, you don't have to write the word shape, but it kind of helps us remember everything. Shape, outliers, center, and variability. So the shape, it's kind of hard to see based on the box plot, but the dot plot's definitely a little easier to see. We've got a little peak over here on the left side, and on the right side, this looks a little more drawn out on the right side than it does on the left. So 2 things that I would probably take as a teacher would be either you could say this is right skewed, or you could say that this is approximately symmetric. It's really difficult to tell with not a whole lot of data in the chart. But I think the fact that we have a peak on the left side would make me want to say that the number of AP courses, is skewed right, or right skewed. Okay. How about, what can we say about outliers? Well, it's a very small, narrow range for the data, just from 1 through 6. So I would say there are no outliers. Okay. What's next? Center. Okay. So when you answer the next 2 questions, you need to answer them with a statistical measurement to back up your claims. So the center, a good way of measuring the center would be the median. So the median number of AP courses is 3. We found that right over here. That was like the first thing we did. And then lastly, variability. We can figure out IQR. So the IQR for number of AP courses is, well, it's Q3 minus Q1. I'm looking at Q3 here. I'm looking at Q1 here. 5 minus 3 is 2. 2 courses. Or just 2 in this case. I think courses is already built into our context. Which actually brings up the other good point is while you're describing this, it's always important that you add context to your description. So if we're talking about number of AP courses, this description better say number of AP courses at least once, if not everywhere. So shape, outliers, center, variability, put it in context, and you got yourself a good description. Okay, we're going to move on to question 6, which is a review of voter registration records the small town records in a small town yielded the following number of males and females registered as Republican, Democrat, or some other affiliation. Create a segmented bar graph showing the distribution of political party for each gender. That means I want a bar for males and I want a bar for females. It says a segmented bar graph for each gender. So a segmented bar graph for the male, segmented bar graph for the females. Do the data provide evidence of an association between gender and party affiliation? So here's what we're going to do. We're going to take a look at just the males right now. And we're going to describe the males. So what percentage of the males are Democrat? Well, how many males are Democrat? 300. Out of how many? Well, it looks like there are 1,000 males. That's 300 plus 500 plus 200. So out of 1,000 males, and that gives us 0.3, which is 30%. Okay. How many males are Republican? Well, that's 500 out of 1,000. And I don't think you need to be too much of a genius to see that that's 50%. Uh-oh. 50%. And then what about other? Well, that's going to be, what is that, 200 out of 1,000? Yeah, 20%. So that is our distribution for the males. It's a conditional distribution, really, because it's on the condition that we're looking only at males. Let's do the same thing for the females. So we got ourselves, how much is that? 10%, 60% Democrat, 30% Republican, and 10% other. The next step here is to draw our bar graphs. Basically, we're going to draw two bars, one for males, one for females, and they're going to be the same height. And that height is going to be 100%. Okay, we have two bars now, one bar that says males and one bar that says females. And now we're going to portion them out. 30% of that male bar should be Democrat. So we're going to eyeball where's 30% about. Let's see, if that's 50% right in the middle, then 30% should be right about here. The next thing is 50% would be Republicans, so I'm guessing that's about 50% right here. Ooh. 50% would be right about there. Maybe I should move that 30% bar down just a little bit. It's a good idea to be able to move this stuff. Yeah, that looks a little bit better. Good. So we're all proportioned. This looks like about 30% down here, 50% in the middle for Republicans, and 20% up here for the other. Maybe I should make that a little bit smaller too, a little higher. All right, so that makes me feel better. Let's see, the bottom here, that's going to be the Democrats. We'll color them yellow. Then over here for a key, we'll make the yellow color Democrats. The next color I have is blue. That's going to be for the Republicans. That's going to be Republicans. And the last color I have, well, I'm going to have to dig for that last color. We'll make it green. That's going to be other. And then we're going to do something the same, well, not something similar, the exact same thing for the females, only this time we're going to do 60% Democrat. And then we're going to do 30% Republican. And then 10% other. So here are the segmented bar graphs. And the question you need to ask yourself, do the male and female bars look reasonably similar to each other? And I think you would have to say that the male segmented bar graph does not look reasonably similar to the female segmented bar graph. So if they don't look the same, that means that there is evidence of association between the gender and the party affiliation. So we would probably say that females are more likely to be a Democrat when compared to the rest of the females than a male is going to be likely to be a Democrat when compared to the other males. So that is what we mean by an association. And again, if the two, well, maybe going back on the same thing, if the two segmented bar graphs looked similar or reasonably similar, then we would say that there is no evidence of an association. Okay, so and that starts us thinking about independence between the two categorical variables in this case. So let's keep on going. We've got 7 through 10. Here's number 7. Each of the two histograms represent the distribution of acceptance rates among 25 business schools in 1995. The histogram uses different class intervals, but they are based on the same data. So important, we're looking at the same data in both graphs. In each class interval, the left endpoint is included, but not the right. So for example, if I look at this first one, this first bar is greater than equal to 10, but strictly less than 15. So here, we're going to try to figure out which of these bar graphs for 7 is better to answer the question What percent of schools have an acceptance rate that's less than 20%? So you ask yourself, which of these two bar graphs is better suited to answering the question? Well, I can see a clear 20% here, but I'd have to guess where the 20% is on the second bar graph or histogram. So I'm going to pick this first one to answer the question. And let's see. We've got the first bar. Everything in the first bar is less than 25. Less than 20%. And everything in the first bar is less than 20%. So how many schools is that? Well, this is 3 schools and 1 school. So that's a total of 4 schools out of the 25 business schools. So this answer is 4 out of the 25 business schools. And that is, what, 16%? So 16% of those business schools have an acceptance rate that's less than 20%. So that's a lot of percentages being thrown around, which makes your head kind of spin a little bit when you try to answer this question. So, again, good luck to you. That's why you're the smartest people in the room, right? Let's take a look at letter 8. It's based on the same information, the same graphs. Which interval contains less than half of the observations? So let's remember that there are 25 observations. So less than half of the observations, well, that would be 12 or less. Yeah, 12 or less. So are there 12 or less schools between 20 and 35? So between 20 and 35, that includes... Well, let me get rid of this color. Between 20 and 35 would be these 3 bars. 1, 2, 3. Is that less than 13 schools? Or is that, less, 12 schools or less? 5, 10, 13. So this first bar is 5 schools. The second bar is 3 schools. This last bar is another 5 schools. That's a total of 13 schools, and that's not less than half of the schools. So we'd have to say no to the first one, because that is 13 out of 25. That's not less than half. How about between 25 and 40? Let's highlight those bars. Between 25 and 40... Okay, that's 3 schools, another 5 schools, and then another 5 schools. Again, that's 13 out of 25 schools. That's not less than half. Now, letter C, we're going to have to use the other graph. That's between 22.5 and 37.5. So how does this even work? Let's see, 7.5 to 15, 15 to 22.5. So each one of these bars is going to be 7.5 percentage rates. So where's 22.5? That's here, 22.5, and then 37.5 is going to be here. And how many schools is that? Well, this bar is 5, it looks like, and this bar is 8. 5 and 8 is 13 schools. So no, that's 13 out of 25 again. Which brings us to the one that better be the correct answer, which is between 30 and 45. Here's 30. Oh, nope. 45 is going to be better shown here. So between 30 and 45, that includes these 2 bars and this last bar over here. So let's count. That's 5 schools, 10 schools, 11 schools. Yeah, that's just 11 out of 25. Our correct answer should be letter D. almost finished here. I can feel it come to an end. So let's take a look at number 9. This is a little bit of a trick question here. So Consumers Union measured the gas mileage in miles per gallon of 38 1978 to 1979 model automobiles on a special test track. The pie chart below, really above, provides information about the country of manufacture of the model cars used by the Consumer Union. So remember, they're telling you where the car was manufactured, not the mileage of the car. Based on the pie chart, we can conclude. So we can't conclude anything about the mileage of the car. We can only conclude things about where the cars are from. So letter A, Japanese cars get significantly lower gas mileage than other countries. We can't make any decisions that are based on gas mileage, only country of origin. B, U.S. cars get significantly higher gas mileage. Same thinking. Can't tell anything about the gas mileage based on this pie chart because this pie chart is for the country of manufacture. C, Swedish cars get gas mileages that are between... Okay, so I'm not even going to finish reading that because that's concluding about gas mileage again. Letter D, Mercedes, Audi, Porsche, and BMW represent approximately a quarter of the cars tested. Well, where are Mercedes, Audi, Porsche, and BMW? I think you're supposed to know that those are German cars. And if you take a look at the German slice, that is definitely not 25%. 25% would represent a quarter of the pie. That is not a quarter of the pie. So letter D should be incorrect. Which brings us to E. More than half the cars were from the United States. And taking a look at the U.S. slice of pie, that does look like more than half of the pie, doesn't it? It's so much of the pie that it's going to take me forever to highlight the U.S. pie. Okay, so that's more than half the pie. So that has to be the correct answer right here, letter E. More than half of the cars in the study are from the U.S. Now, remember, it's not asking anything about the actual mileage. It's just asking about the country of origin. Finally, that brings us to number 10, which looks like I'm going to have to shove up a little bit. Okay, here we go. The following histogram shows the actual frequency of closing prices on the New York Exchange on a particular stock. So one particular stock. Based on the frequency histogram for the New York Stock Exchange, the class that contains the 80th percentile is... Okay, so we never talked about percentile in class. So I'm guessing that if that's your class, then this question shouldn't be on your test. However, we better answer this question because, well, I can't not answer it. So where is the 80th percentile? Well, how many closing prices do we have? We have 13 plus 8, that's 21. 21 plus 15, that's 31, 36. 36 plus 7, that's 43. Plus 2 is 45. Plus 3 is 48, 49, and 50. So these are 50 stock, or 50 closing prices. Okay. Where would the 80th percentile be? Well, what is 80% of 50? So 80% of 50, that's going to be equal to, well, that's going to be 40. So the question is, where is the 40th closing price from the bottom? Well, where would it be? Well, we're going to go in order again from the lowest to the highest. Where would the 40th be? Well, this first bar would be the 1 through 13. Okay. If you add on the second bar, the first two bars would be 1 through 21. The first three bars would be 1 through, what is that, 36? 1 through 36. And the first four bars would be 1 through 43. So it looks as though the 40th price from the bottom would be included in this bar here, which is between 30 and 40. 30 and 40, which would be, I don't know why that says J, that really should be E. But that would be the 40th percentile. It would be the 80th percentile. 80% of 50 is 40, so we're looking for the 40th stock price from the bottom. The other way of doing that would be the 10th stock price from the top, but that's a little more advanced than I really want to get. So that takes care of it, folks. That's the entire Chapter 10 practice test. Hopefully that was helpful, and we'll see you next time when we talk about more statistics. Have a good day.